that they cannot fly certain connections anymore because it just doesn't make sense. I'm not really fully aware of that, but what I know is that, of course, when I look at the task of my company, we have a big traffic concentration now in the southern part of Germany in the upper airspace, where we have reached traffic amounts that exceed the numbers we saw in 2019 before Corona.
Wow.
Yes. Yeah. So just looking at the average doesn't make sense when you have a traffic concentration, because then you have a bottleneck where you don't need it.
Welcome to the Aerospace Ambition podcast. In this episode, we'll explore innovation that is taking place in air traffic management. I'm Marius, an aerospace engineer and your host. My co-pilot today is Kshitija Desai, a mechanical engineer and aviation enthusiast. I'm very happy for you to be here and would like to welcome you to the show. Hi, Kshitija.
Hi.
So great to have you as the co-pilot for our interview guest today, and I'm very excited to have him here. Our guest today is Jörg Buxbaum from the German ANSP, or Deutsche Flugsicherung, or short DFS. Jörg Buxbaum works in the DFS research department. After graduating in aerospace engineering in 1997, he began his career at Frankfurt Airport and soon transitioned to air traffic control. He started as an assistant to the managing director, technical operations, and subsequently held several leadership positions, including head of Frankfurt approach control. After a period with the US Federal Aviation Administration, FAA, he returned to the DFS in 2009 as a team leader at the DFS Research Center, where he is responsible for technical and operational future developments. Jörg, welcome to the show.
Thank you, Marius. I'm glad to be here.
Glad to have you. And something I have not mentioned in the introduction is the fact that you're writing a dissertation at the Technical University of Braunschweig on the topic benefits of automation in air traffic control. So my first question when I heard this was, how many hours does your day have?
Actually, it's not enough. So I would love to have more time, not for work, but for leisure. So in the moment, there's not a quite balance between my focus on my professional jobs and the things that are combined with it. What really helps me is that the topic of my dissertation is really strongly combined with the day-to-day work in my job.
Yeah, a lot of synergy there.
Yeah.
And following up on this, how does your day-to-day look like then? And what is the most exciting thing that you're working on at the moment?
Actually, so normally when you think about research and development, you might have the image that people are sitting there and not really talking, but thinking and writing down things. And in reality, it's just the opposite. So being a team leader in R&D means I have to really get into conversation with many people in the company, with the customers, with other scientists, and really figure out what needs to be done. So what's essential for our future? What really is the topic we have to look at? And this is not necessarily the topic we have on our agenda, but sometimes we have to point at things and say, okay, in 5 or 10 years, we'll be perhaps facing a problem we have to think about right now. And this means R&D is conversation and talking to each other, most of the time in a quite informal way, because you have to free your mind in order to think about challenges and the way to solve them. And so I would say that 80% of my time is talking, thinking, and doing proper conversation in frames like a workshop or other things. Yes.
Great.
Yeah, I can imagine that workshops play a huge role here, and it's a balance between understanding the complexity of the presence, but also always looking ahead, and not only looking ahead in terms of weeks, months, or a couple of years, but maybe even decades. And to open up the topic of air traffic management or even sustainability in air traffic management, could you draw us a picture of what we are actually managing here? And what is so special about air traffic management in terms of the complexity or even the sheer number of vehicles or aircraft in the sky that are being managed?
I think what is special is there are basically two perspectives on air traffic. You can either say, okay, let's take a look at one single aircraft flying from A to B, and everyone does its best to make this flight happen in a safe, efficient, and environmentally orientated manner. That means directly, without any holdings or long transitions whatsoever. This is one part of the story, and this is normally the pilot's or airline's view. So what happens when you touch our task of air traffic control is there is not one single flight, but there are hundreds of flights at a given time that we need to cope with. That means we have to ensure that for every of those, let's say 400 or 450 flights that take place in each second throughout the normal day in Germany, we have to ensure the safety, we have to ensure there's no delay or a minimum of delay, and we have to ensure that for the single flights, the optimum routing is being realized. And this is a very specific task, and it's different to looking at only one aircraft.
Yeah.
But I didn't answer your first question, Teacher, because you were asking what is my most interesting topic today, and actually we did a workshop on Monday where we had only 3 hours in order to make up our minds in a very specific way which challenges we face in the year 2040, operationally wise, together with air traffic controllers, the management, and scientists from our department, and then to derive what needs to be adopted in the operations and what needs to be ensured technically in order to make this operations in the year 2040 a reality. And this was really, really brilliant because we brought together all the talents we had in reach and had really good results in just 3 hours. And this is that was a highlight of the week.
Wow.
Amazing. And since you're talking about the future and you're working on the future of ATM, how would you illustrate the anticipated growth in aviation over the coming decades?
I have no idea. Well, my company doesn't have any aircraft specifically. We don't buy them. And even if you know that I think Airbus alone has a backlog of 8,000 orders of aircraft, you might say, okay, in the next 10 years, there will be 8,000 more aircraft flying around worldwide, only with the Airbus logo on it. But then the big question is, okay, so which share of this amount of new aircraft will be replacing older aircraft that will be transferred to Coca-Cola bins or whatsoever? And which one will be adding more traffic worldwide? And the second question is, okay, so even if of these 8,000, let's say that half of them, so 5,000 will be new, where will they be flying? Will they touch German airspace? Will they fly between China and India? Will they fly between South America and North America? We don't know. And this is something we have to look at. And sometimes it's from one day to the other, traffic streams change. And this happened when the Ukraine war started and the airspace was blocked from one day to the other. All the traffic had to be rearranged in Europe as well. That means from one day to the other, traffic streams even in Germany, were not the way we used to have them, and we had to really adopt. And this is one specific thing. Air traffic control has to adapt to the situation. So whatever is needed from us in terms of safety and capacity, we have to deliver. And that might lead us to the conclusion that it's good to prepare for the worst. That means to prepare for a high growth, because we need time to implement technical and operational measures to cope with this traffic. And if we don't prepare ourselves, we perhaps face a situation 15 years where we say, whoa, I'm sorry, there's a lack of 20% of capacity and this is not bearable.
I'd like to follow up on the aspect that you just mentioned, and that is the Ukrainian war and the fact that it massively changed, the routes, especially between Europe and Asia. Is there a way to quantify how much more inefficient, those long-haul flights have become ever since?
It depends. And looking onto this from NSP perspective is perhaps not the right way, because normally you have to ask an airline and they will tell you, woo, for the city pair, let's say London, Singapore, it's a big mess. And especially I heard that the Scandinavian states have really problems because they cannot use the most optimum routing anymore. And sometimes it's even that they cannot fly certain connections anymore because it just doesn't make sense. I'm not really fully aware of that, but what I know is that, of course, when I look at the task of my company, we have a big traffic concentration now in the southern part of Germany in the upper airspace, where we have reached traffic amounts that exceed the numbers we saw in 2019 before Corona.
Wow. Okay, so in that local region, it already exceeds what we had before Corona.
Yeah. So just looking at the average doesn't make sense when you have a traffic concentration, because then you have a bottleneck where you don't need it.
Yeah, that totally makes sense. Some groundwork that we could do here as well, since we have you here on the show, is the fact, what goals are we trying to pursue here in the first place? I mean, one could say, easy, we want to make it, sustainability. Sustainability is the main, aspect that we are optimizing for. But I remember you pointing out that, hey, we as an ANSP, we also have other goals that, we need to find compromises for. And that is obviously safety. It is capacity as well. And then there's also the aspect of cost. So maybe you could just try to give us a sense of, the tension that you face between those different kinds of goals, or where there's an overlap between those goals.
Yeah. You can imagine that when you mention compromise and safety, I have to say, okay, no, there's no compromise in safety aspects in air traffic control. Safety is first, and safety is first, and safety is first. That's the whole point. But you are absolutely right. We have 4 performance areas that we have to face. One being safety, then capacity, cost efficiency, and of course environment. But when you really look into them, you see they are strongly connected. Just to give you an example, if we raise the capacity in German airspace because there's more traffic demand, and we end up having 20% more flights flying daily in our airspace, and if you want to keep the safety level on the high level we have reached nowadays, you have to do something, because it's more dense. There are more chances of aircraft flying close to each other. You have lower reaction time if there's a problem. You have lower resolution probabilities when you try to diverge them after an encounter. So you have to raise the safety per flight in order to keep the safety level of the whole system at the level we have reached so far, and we don't want to leave it. And this means these KPIs are really strongly connected. And just looking at environment, if everyone flying in German airspace and approaching German airports would do a perfect descent, so fluently and without any steps in between, that would raise the complexity in German airspace, and we would have to face safety concerns as well. So we have to find a balance between those different key performance areas. And balance means safety first, and then we talk about the rest.
Since you've mentioned already the fact that some flight trajectories are getting closer and closer, it's exactly what I observed the other day when I was on a flight, and just looking out of the window, listening to a podcast maybe, and then I just saw, all these aircraft passing by, and I was wondering, this is really close. So yeah, it's also my perception that this is getting much more close. And the topic of continuous descent operations is something I want to link to this observation, because for me, it seems that whenever you change, continuous descent operations essentially mean that you don't walk down the stairs, but you walk down the hill, let's say, more continuously. And obviously, in terms of creating space between trajectories and between flights, that makes it more challenging, I suppose. So is this just my perception that, trajectories are getting closer to each other, or is there also a way to quantify this? And then another follow-up question later on CDO.
It's really hard to quantify the CDO effects, but what we have observed so far, and this one was presented at the Deutsche Luft- und Raumfahrt-Kongress last year in Stuttgart, was we really face separation issue when we offer the majority of incoming arrivals to a hub airport a perfect CDO approach. That's for sure. So it's not very hard to offer. And again, looking at one single flight, it's very easy to offer a perfect CDO approach. You have to talk to the upper control center, which might perhaps be in France or in Sweden or in Poland, because the top of descent normally when aircraft approach German airports is not in Germany. It's somewhere out there, and so you have to coordinate at a very early stage where to start the descent and how to make this descent in a way that is most efficiency concerning energy consumption and CO2 emission. And this means you have to coordinate each aircraft and each descent in a way that the CDO later on is performed in an efficient and, of course, safely manner. And there is no technical system out there to provide air traffic control, if it's in Germany or Switzerland or France, to provide the air traffic controller with a proper idea how to bring, let's say, 45 arrivals per hour on a specific runway or two specific runways in a way that there's an optimum arrival path for each aircraft. So we have to find ways to learn what is the optimum trajectory of each incoming flight. We have to talk to the pilots, or we have to have data that allows us to evaluate which is the perfect flight path. And then we have to bring together the different prognoses of different flight paths and find an overall optimum on this regarding, again, safety and capacity. Because it doesn't make sense to have the landing rate at, let's say, Munich drop from 45 to 32, but to allow 90% of the aircraft being CDO approaches. So nobody would be really happy with that.
Right.
Right. And as the demand is growing and we know that there's a lack of ATCOs, will we have to tackle this growth by hiring more ATCOs, or what is the solution that the industry envisions?
It depends. So normally ATCs worldwide rely on what they have because the main idea of air traffic control is to maintain and to ensure safety in the air and on the ground where aircraft are controlled as well by ATC on different airports. So when you want to ensure safety, you rely normally on the measures you know and that work. And that means if there's more traffic and you have more ATC operators, ATCOs, it's a good idea because we know how this process works. When we get away from this path and say, okay, let's say we don't want to raise the amount of air traffic controllers in the same way as the traffic grows, you have to rethink things. And this is where it gets really interesting, because then you have to look at measures where there's no real experience in the past. You have to look at more assistance by the computer, more precise prognosis of trajectories, putting down workload and task load at the air traffic controller workspace and other things. And this is all a big field of R&D. But what I would like to ask you, how do you think for the last, let's say, 20 or 25 years in Germany, I mean, there was a traffic rise of, let's say, 30 to 40% in the span of time. What do you think, to which extent we have now more air traffic controllers than we used to have 25 years ago?
So, of course, there are two things that need to be considered. One is that growth, but of course, the other one is more efficient ATM.
Yes.
And now the question is which effect overweighs, right? 30 to 40% is significant, but I would just say that it was only 20% of an increase, so only half of that. I can read from your body language, it's completely off. But I'd say it's only 20% increase, in proportion to 40% of increase in traffic.
That would be very good, because that would mean that our efficiency has been raised throughout this 2 decades as well. So the answer is roughly, and I really say roughly, we have round about 2,000 air traffic controllers at DFS, at my company. And this is nearly exact the amount of air traffic controllers we used to have end of the 90s. So, but what happened in between, and we are not really sure to which extent which measure has really an effect on the fact that the amount of air traffic controllers has remained stable and the air traffic grew to 30 or 40% meanwhile. So it's, as always in a complex system, is the result of different actions. One being there's more automation, there's more the system provides to air traffic controllers to do a safe and efficient job. The other thing is, okay, we have adopted our airspace. We have adopted the shifting scheme and the rostering scheme for air traffic controllers. So we had many little points that we changed, and the overall effect was really impressive. And this is something when people talk about air traffic management and they complain about delay and they said you are too expensive, I tend to say, hey, look at this fact. We have a stable amount of air traffic controllers, and it's our will as a company to keep this amount nearly stable and to continue having a decoupled effect of traffic growth and amount of air traffic controllers. The only thing we have to ensure is we don't want the workload for each controller to rise to an extent where it's not bearable concerning safety, of course. So they have to be supported by the technical system in the future more than we experienced this 20 or 30 years ago.
Yeah, and I mean, one aspect is the sheer number of flights that need to be managed by one controller, but the other one is also the complexity. You know, if the same number of flights is there, but they, these flights come together in a more complex environment and more complex situation, that can also put stress on the controllers. And that leads to the topic of, how can we support these controllers? How can we include innovative technologies to enhance their work, or maybe enable them to have a higher workload, but the same level of stress and the same level of reliability as well. So using the buzzword AI here, we have to be very careful, and it's a podcast, but I always use air quotes when I say this. Maybe you could give us a definition of AI, because I remember on a slide that you presented that you quoted someone as to AI is whatever has not been done yet.
Exactly. Yeah. I think that was Larry Tesler. He was the inventor of the copy and paste method everyone knows. And I like this definition very much, because there are so many definitions of AI on the market. You really can mix and match whatever you like to what fits to your needs. But this is very important, because we in many discussions we face the fact that people tend to say, "Oh, I'm afraid of AI because AI will replace humans and there will be robots in the future, and we rely on the technology and not on the humans anymore." And then I tend to say, okay, but you are swiping on your smartphone, you're using voice recognition on your smartphone. This is all AI driven. Nobody talks about it anymore because it has really found its way into everyday tasks. And same now happens with ChatGPT and other large language models and generative AI. So, which is new today, will be normal in 3 or 4 or 5 years. And so this is one very, very important thing we have to look at when we look at AI applications in air traffic control. On the other hand, of course, we do not plan to introduce AI for separation tasks in air traffic control in the next 5 years. I mean, that would not fit to our mindset that we have to provide 100% safety in German airspace, because the technology concerning safety relevant actions is not that derived to this point. We have to start at applications where we learn, where we have a early use of AI, and then to look further. But coming back to this point that you mentioned, Marius, that the complexity in an airspace is the result of different aircraft behaving differently. This is one specific thing where we think that AI may help us in the future. Because when you use machine learning in order to learn in which situations in which weather situations, in which traffic situations, which workload and which complexity was achieved at the air traffic controller workplace, you can, if there's a similar situation, say, okay, I've seen this before. In 5 minutes, you'll be facing a very high complexity situation due to the fact that these 2 flights I depict you on the screen will cause trouble. And 5 or 10 minutes ahead, these flights perhaps are still in the sector that is feeding my sector. So I have to talk to the other controllers and to put a relief on the situation that has not been developed yet. And this is one very specific thing I expect from AI in the far future, that it helps us to see and to early see points and regions and possible conflicts that we are not able to see right now. But coming back to because this is very in the distant future, of course. We are not there yet, but we make up our minds. And currently we are rolling out an AI initiative in DFS where we look at AI applications in the different branches of my company. But looking at the air traffic controller and its workplace, using speech recognition in order to make it easier for the air traffic controller to have different views on the screen, to receive information, to receive information about surrounding sectors, that would be a first entry into using AI for the air traffic controller's business. And speech recognition, it's out there. I mean, everyone uses it, and why not using it for operational purposes?
Yeah, absolutely. Speech recognition, super interesting aspect. And another one, since you gave us this exercise of estimating, the growth in headcount, let's say, of air traffic controllers, my perception is that a huge role played in this higher efficiency was the fact that you can dynamically, shift, what area is a controller responsible for. It's also something that I observe with the virtual towers, where we have a digital representation of a tower, but that tower could be responsible of an airport A, or if, there is a very high demand at a different airport, you could then switch to that airport. So the ability to dynamically have the supply for a certain demand, let's say, I think is a core ability of air traffic management. And that's why I quite like this explanation of yours when you say we need AI at least to be able to predict when will there be a complex situation or, a high demand, because then we are able to ramp up the resources beforehand. Right. So it totally makes sense that this is a core competency. And of course, since air traffic control is to a large part defined through language still, language recognition also plays a huge role.
Yeah.
And is there a way to structure maybe, the different levels of escalation or the different levels of impact? For example, I could imagine there is an AI that manages, the entire traffic on its own. That's the highest level. But then there could be also an AI that just supports me and, for example, highlights in a different NOTAM or in a different, text that I receive the important terms, that would be a rather supportive function.
Yeah.
Is there a way to structure this, the different levels of escalation?
I think so. And doing a stepwise approach in these AI applications is always a good idea in aviation, because aviation, even looking at Boeing or Airbus or whomsoever, we are not really good in big bang solutions. And we don't need to. I mean, it's all evolution, and it's a good way to start at a certain point, look at useful applications, and then to think further. And yes, of course. I mean, there are so many regulations and rules out there for air traffic controllers. It would be a very good idea to use AI in a certified manner in order to bring together the relevant information in a very short time. Because normally when you're an air traffic controller and to come to your workplace and it says, okay, there are new departure routes in Frankfurt Airport and this is important and that is important. And you have to read lots of material to get to know what to do from your next shift on. And it would be interesting to have an AI helping you in deriving the relevant information. This is because you talked about flexibility, and this is a very, very big issue for the future as well. So we are, of course, very good in flexible use of airspace, not only in the civil military aspect, but also in the aspect to offer the capacity at regions where we need the capacity. So we can concentrate air traffic controllers in areas where there's a very high traffic density, but there's still more potential. And flexibility is, I would say, it's the underlying key performance area of the 4 ones we talked about today already. So if you are more flexible, if you can put air traffic controllers in a very, very short span of time to areas where they can really help, that would help either capacity or environment or whatsoever. So it's a good idea not only to look at the 4 big key performance areas, but to flexibility as well. And on the long run, I have the hope and the impression that AI will really help us in making our work more flexible, because the thing that prevents us from putting air traffic controllers somewhere in the Republic is that there are so many regional specific knowledge you need to know in order to work there. So to help the humans looking at the relevant information for this specific area would really drive our flexibility in the far future.
Yes, that's very interesting to know. And Jörg, can you elaborate a little bit more on the potential applications of AI throughout the course of flight? This could be something interesting to know from your perspective.
The problem is that there's not only a few, there are so many potential applications of AI throughout a flight that we have to think where to concentrate our efforts. And this is a thing that really happens right now. You can do hundreds of things. The question is which impact are behind those efforts and which risks are combined with those things. So, but answering your question, it's very easy starting at that point when you say, okay, a flight is about to depart. AI can help us with a prognosis of weather and capacity at airports, either if it's for landing or for departing, or the overall coordination value that can be achieved. The weather impact prognosis is very relevant. And then whenever the aircraft is airborne, one of the major things where we see a high potential of AI is having a better view on the trajectory prediction for the next 5, 6, 7, 10 minutes. Because in the moment, we are not there yet. It's really hard to estimate where a specific aircraft will be in the next 10 minutes concerning its 4 dimensions, so the spatial ones and the time. And adding on this, of course, humans and machines together are very good in conflict detection. So there are certain warning systems working at air traffic control, let's say a medium-term conflict detection or short-term conflict alert, where air traffic controllers are being focused on specific pairings that need their attention. But what we could estimate and what would be a great chance in the far future would have an AI derive proper and really intelligent conflict resolutions that base upon experience from the past. So if you feed a machine learning algorithm with traffic of 1 year or 2 years in German airspace, you can really find out, together with the transmissions or the releases from the air traffic controllers, from the clearances, that which solutions were really working out well, and you could use them in order to offer them to the air traffic controller in a new specific situation on an operational day. And then they have, of course, the AI support for energy efficient approaches. We talked about CDOs as well. I see a potential for AI in order to make proper suggestions how to control 45 aircraft flying in an hour to, let's say, Munich airport in a way that there's the most optimum approach for each aircraft and the overall safety and capacity is maintained in the level we have achieved so far. And I think it's worth looking at the AI potentials and not only relying on conventional algorithms to do so. And finally, of course, at each big German airport, there's an arrival management system in place, and we have already developed AI solutions in order to optimize those systems. And again, by automatically looking into the huge data of the past, we are more and better able to see into the future and provide the air traffic controllers with a proper suggestion on how to behave. But, which is very important, not in order to tell him or her what to do, but to offer something, to offer solutions and to offer options. And it's still up to the human to decide if it's a good idea or not, which is very important. We still are heading for the human-oriented approach. That means we like to have the responsibility for decisions in air traffic control being in the minds of highly specialized and highly trained air traffic controllers.
Makes sense.
For sure. I mean, thinking about 45 aircraft an hour, that already just is mind-blowing. If you really visualize, these heavy aircraft and, the spacing that is required in between, the vortices that they have, create in the air and all the safety aspects that need to be taken into account. It's crazy, but it's promising to hear that there are some aspects where AI could, help us. And another area where AI or some elements of machine learning are being used is contrail management. For example, in the detection of contrails, of the contrail clouds, through satellite images. There are also ways to predict the emergence of these persistent warming contrails through an end-to-end machine learning pipeline, as is being done by Google, for instance. And when we look at contrail management, it's super important to include the perspective of an ANSP as well. So I'd like to start off with a little bit of a funny question, but do you have an unpopular opinion on this topic? In the field of contrail management, is there something that very few people agree with you on?
I think so. I think we're at the beginning of discussions about this topic. And what we haven't really discussed until the end is how to deal with the fact that in this case, environment is again also in struggle with capacity. So when you have all aircraft that are perhaps crossing zones where there are contrails evolving that will be climate damaging, and you keep them on the lower level, that means there's a traffic concentration perhaps exceeding our capacity. How to deal with that? And we have, of course, to talk about where to introduce contrail-optimized flight trajectories. And what I can tell you, perhaps it would be a good idea not to start in the middle of Germany, because this is the most complex airspace in the world, together with the east coast of the US. So perhaps we come to the point where we say, okay, we have some conclusions on this topic, and we learned how to deal with it, but better not start with contrail management in the central part of Europe, but perhaps in the North Atlantic tracks. So we have to have this discussion that has not started yet.
That's an interesting observation. And now I understand why you picked that aspect to answer my cheeky kind of a question, especially because Europe is usually at the forefront when it comes to implementing sustainable policies, right? So of course, we also want to be a driving force when it comes to trialing out these things, but we have to respect the different levels of complexity, the different levels of scale as well. For example, maybe over the northern part of the Atlantic, where persistent warming contrails have a particular impact, negative for the environment. Maybe that is an area where we could start first. So yeah, I totally appreciate that opinion here.
Yes, but it's kind of delicate, because when you say, hey, we found out how to do it, now somebody else can do it, it's always combined with a certain, not in my backyard. And you have to discuss this topic on a scientific basis and say, okay, where does it really make sense to introduce those methods and make best use out of it, and perhaps not in the central part of Europe from the first beginning.
Yeah. Following up on this, how do you plan, or what is your opinion about how do we balance the need of efficient air traffic management with the environmental goal of reducing contrail formation?
this has to be discussed. We have to look at the results of the trials and calculations, and we are not there yet. So we don't have the facts in order to decide what to do and which really makes sense. And there's so many questions still unanswered. Being from R&D, I like unanswered questions because that's the thing we love to look at. But the sheer amount of questions concerning this topic is really overwhelming, and there are so many open items in this. But hey, still we go there stepwise, and I think it was in March when DFS together with surrounding air traffic control centers started the 100 flights trial, where we tried to calculate the optimum way to have flights guided through the airspace without forming bad contrails, and we still have to rethink what the results mean. And one aspect being, and I'm not really in this project very, very deep, but I can tell you it's always a good idea to have the decision about the flight routing before takeoff and not on the operational basis. So not doing recalculations during the flight and suddenly 5 or 6 pilots call in and say, we would like to fly certain amounts of flight levels lower. This really would cause trouble in air traffic control, because then we perhaps would exceed our capacity limits.
Oh, that's an interesting one.
Yes.
Yeah, this has to be more strategically planned, and then we need more and better predictions around contrails, the areas where the contrails are formed and so on.
Exactly.
Yes.
It's an interesting one. Maybe that's also an unpopular opinion, because there are, it seems, parties that prefer a decentralized approach. So it's driven by the operator coming from the cockpit. And then there is this central approach. For example, in the MUAC trials, an entire airspace was blocked out. That's the extreme. And it's something, for example, also Sean Andrews from NETS said that it's not the solution going forward, obviously. But maybe you could manage it still centrally and just say, okay, a central ANSP kind of institution would focus on a certain area, a certain region, which, is prone to creating persistent warming contrails, also known as ice supersaturated regions. And then you could maybe take a more nuanced approach and not block out the airspace and, divert all the flights, but maybe you could pick the big hitting flights, and just divert them. But what is your take on the debate, central approach versus decentral approach?
I have no real final conclusion on that, because the scientists still are looking at this topic. And when it comes to the point, okay, how to make a proper prognosis where these areas are building up. And in Europe and in the US as well, we have a very long tradition of talking about decentralized and centralized approaches. And when you look at the demand capacity balancing, we work very close together with a network management in Brussels. So there are certain tasks being done centralized in Europe and others at the ANSPs or in the centers. I think this discussion has to be held, but in the moment there are not sufficient facts in order to take this as a basis.
Yep, there certainly is still some groundwork to do. The aspect that I mentioned before also implies the question that was asked from our previous guest in the tradition of this podcast. And the previous guest was Jonas Sperling from Lufthansa Systems. And his question was to you: what is your plan for providing the contrail regions to your controllers? And maybe you've already done a study for this.
I'm not very deep in this project, but I wouldn't like to overwhelm our air traffic controllers with meteorological information on the primary radar screen, because their primary goal is to maintain safety and capacity and optimum routings. So what I would imagine is that there are certain hints and information on the screen in order to help the air traffic controllers to offer the optimum flight path, but not in the way that we show them the zones or the areas or whatsoever. So I don't want to have the cognitive workload being derived to the controller, but I would like to help them and give them information what to do with certain flights if feasible.
This is exactly why we need to ask people like you this question to have a very differentiated and nuanced discussion in this, and include really hands-on perspectives. And another thing I really wanted to include in our conversation today is the tiny comment that you made during one of your presentations when you just said, hey, guys, we also have to consider some more aspects. For example, if we in the future, have a higher share of SAF, and some, there are higher blends of SAF being fueled on the aircraft. Now, should we then try to prioritize these aircraft that have SAF on them, because we want to incentivize, in a positive way, these aircraft for fueling the more expensive fuel here and more sustainable fuel? Or should they actually be the ones on holding patterns? Because then we know the bad ones that emit more CO2, that don't have the SAF on board, they would create more CO2 emission when sent to a holding pattern. Yeah, maybe you could reflect on that comment, or does it stand on its own?
Either way, I mean, this is a very specific perspective that I was asked to present, because in the moment my company is of course already preferring different aircraft that are following the main idea of best equipped, best served. So there are certain approach procedures in Frankfurt, the so-called Yankee approach, which is a segmented approach that is offered to specific aircraft only. And following this thought, it would be an interesting idea to make up our minds how to incentivize certain flights that are more environmentally oriented than other flights. Because our measures to really have a positive impact on energy efficiency in air traffic is very limited. When we really would offer 100% CDO approaches to flights coming to German airspaces, we perhaps could save 2% of fuel throughout the day, which is not that much. I mean, it's 2%. So, well. But on the other hand, if we find ways to make an incentive and say, okay, so we prefer aircraft that perhaps have an amount or share of 80% sustainable aviation fuel, and they have less delay when starting up or other things, that would be an interesting idea. But we are not still there yet. We have to start the discussions about this, because this is very new to air traffic control worldwide.
So, given your extensive experience in ATM spanning over 2 decades, what lessons can we draw from the past initiatives when considering a realistic timeline for implementing contrail management? Like, how can these insights from our expectations and strategies for this emerging area, like how can we actually draw some insights, and how can we set some expectations for ourselves from your experience?
That's a big question. So overall, I would say things change, things need to be changed, and facing the challenges of the future of air traffic and air traffic control, lots still has to be done. So better start early, not to get in a rush.
I think that's a nice way to put this, especially with such a complex question. And to wrap up this discussion here, there always is this potential improvement, this potential reduction in CO2 emissions of 10% when you speak about air traffic management. And what are, when you look forward, what are the core technologies on a high level or operational improvements that could make this happen, or that are most promising to actually make this happen?
Well, my first part of the answer would to look at the fields we have already achieved. So looking at flight efficiency and looking at the lateral trajectory of flights, we have reached the optimum in Europe concerning the circumstances we face when you look at military exercise areas and other ones. So the difference between the Great Circle distance and the actual flown distance in Europe lies at 2.8%. That means each flight in average has 2.8% longer trajectories in comparison to the Great Circle distance, and which is equivalent to the value in the US, which gives you an idea that perhaps this is a kind of a boundary or a barrier where it doesn't make sense to go any further because you would have to invest so much in order to achieve 0.2% or whatsoever. It just doesn't make sense. So I think it would be a good idea to look at two things: at improving energy efficiency concerning, of course, CDO approaches. We talked about that. And perhaps to see what potential is still there in the approach sections of certain airports in order to minimize the flight time in the vicinity of airports. These are the two ones where I think there's still some potentials in there. You mentioned the 10%. It's not realistic. The 10% is when you look at one flight only, but not 45 an hour at a certain airport or 450 at any given time in Germany. I see the realistic value being there between 3 or 4%. And then you still have to question yourself how to achieve it. What can you really do? What is technically achievable? And what is achievable concerning the resources we need to accomplish that? Or wouldn't it be more wise to invest the resources in other fields in aviation where we have a bigger impact?
Thank you. And now I would like to present you a chance to ask a question to our next guest. That is Madeline Basten from Eurocontrol. Is there something that you would like to ask her?
How would you rate the importance of environment in contrast to the other key performance areas: cost efficiency, capacity, and perhaps safety?
I love it. I mean, any guest who understands this tradition immediately passes on tough questions to the next guest. I think that's the best way to treat this one. But Jörg, this has been an absolute pleasure having you on the show. And I think we've learned a lot today about what are the challenges in ATM, how do we drive innovation, how should we define AI, and what are the potentials to include AI. But also you gave us a pretty realistic estimation of, how to quantify the potential improvement. And I think that's a very important statement in order for us to set the right priorities, both in terms of the monetary investments that we do, but also in terms of the attention, what are we spending our attention on? So thank you very much for being our guest.
Thank you for the chance of talking about those very important topics. Thank you for the splendid questions, and thank you for the nice atmosphere. It was a pleasure.
That's very nice to hear. And one important element of that nice atmosphere that you mentioned was, of course, the brilliant co-moderation of Kshitija. So Kshitija, thanks for making a great first appearance on the Aerospace Ambition podcast.
Thank you so much. And it was a pleasure to be a co-host, a co-pilot for this podcast, and very interesting insights, Jörg. I really appreciate you coming to the show. Thank you.
Thank you.
Absolutely. So thanks to both of you and speak soon.
Tschüss.
Bye-bye.
Danke.